Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology College of Engineering at Ichalkarji, which is at Kolhapur district, Maharashtra. Today we're going to see the direct numerical control in CAD/CAM. We'll see in this the component of DNC system, that is direct numerical control system, functions of DNC systems, types of DNC systems, and advantage of DNC system. So let's get started with introduction. The DNC is a manufacturing system in which a number of machines are controlled by the computer through direct connection and in the real time. The fundamental component is the distribution of control information at the appropriate time to several machines, whereby the computer monitor the functions of the numerical control. The DNC is the system connected a set of NC machine to a common memory for part programming or machine programming storage with provision for on-demand distribution of data to machines. In principle, one large computer can be used to control more than 100 separate machines. Here we can see the components of the DNC, that is central computer, bulk memory, and telecommunication lines and machine tools. Here if you see the figure of general configuration of DNC, this is what a central computer, bulk memory for NC programming, and telecommunication line, and these are the machine tools. The computer calls the part programming instructions from bulk storage and sends them to the individual machine as the needed arises. It also receives data back from the machines. This two ways information flow occurs in a real time, which means that each machine requires for instruction must be satisfied almost instantaneously. Similarly, the computer must always ready to receive the information from the machines and to respond accordingly. The remarkable features of DNC system is that the computer is surviving a large number of separate machines tools all in real time. If you see here, the central computer is connected to a number of machine tools and they control them. Here number of machines are connected to the central computer, connected to the number of machine tools and control them. And the part programming of all machine tools are stored in the memory of the central computer and transmit on the direct transmission line on its demand. The two-way information flow takes place in the real time. The various machine tools can be communicate with the computer in real time as well. The programs in full or segment can be transferred to NC machines. The computer can be used for program editing and all. The no tape readers are used and no limitation for the number of or size of programs stored. So if you see the function of DNC, the functions which a DNC system is designed to perform, that is NC without punched tape. The main objective of a DNC system is to eliminate the use of punched tape. The problem of associated with this N tape are a relatively unreliable tape readers and the fragile nature of the paper tape. And even though last but not the least, the difficulty is in editing the program containing on the punched tape. And the last is the expense associated with the manufacturing equipment of punched tape and the punched tape reader. The problems associated with the punctured tape and costs can be eliminated with the DNC system, that is NC part program storage. The NC the program storage subsystem must be structured to satisfy the several purposes. The management of large if you see the management of large value of NC data in production computer offers considerably more scope for storing and working with the NC programs. The NC data distribution entails making the NC programs available and transmitting the NC data to the machines. The form of a transmission is dependent upon the hardware configurations of the complete system. The DNC program storage system consists of active storage and second storage. The active storage is to store NC programs which are frequently used, and the active storage can be readily accessed by the DNC computer to drive an NC machine in the production. A typical mass storage device for this purpose would be disk. The secondary storage would be used for NC programs which are not frequently used. If you say example of secondary storage include magnetic tape or a tape castle or floppy disks and disk packs, etc. If you see the important functions of the storage systems are, if you see the program must be made available for downloading to the NC machine tools, and the subsystem must be allow a new programs to be entered and or old programs to be deleted and existing programs to be edited at the need arises even though. And here uh, the the storage subsystem must be structured to perform certain data processing and management functions. If you see such as file security, display of programs and manipulation of data. Even though the storage system must be structured to perform certain data processing and management functions, that is you said file security and all those things properly. Now if you see the data collection, processing and reporting, this is data collection and processing and reporting. These functions involve the transfer of data from the machine tool back to the central computer. The basic purpose is to monitor production in the factory. When the machine operator requests a particular NC program, the production computer first tests the compatibility and looks for any bearing with respect to NC machine and program. The data output buffer is prepared and filled, and its acceptance or rejection is transmitted to the requesting terminal in accordance with the results of the tests. If this is an acceptable signal, the transmission of end data to the machine control unit commences. Data are collected on the production piece counts, tool usage, machine utilization, and other factors that measure performance in the factory. These data must be processed by DNC computer so that the reports can be prepared to provide management with the information necessary for running the factory. This is what data collection. If you see the communication, The important communication link in a DNC system are between that communication network is required to accomplish the previous functions of DNC. And the essential communication link in DNC are between the following components of the system, that is center, computer and machine tools, central computer and NC part programmer terminal, and the last one is central computer and bulk memory as we saw. If we see, there are two alternative systems configurations by which the communication link is established between the control computer and the machine tool. First is behind the tape reader, that is BTR system, and the special machine control unit, that is SMCU, system. If you see the BTR system, in this arrangement the computer link directly to the regular NC control unit. The replacement of the tape reader by the telecommunication line to the DNC computer is what gives the BTR configuration its name. The connection with the computer is made between the tape reader and the controller unit behind the tape reader. If you see, except for the source of the command instructions, the operations of the system is very similar to the conventional NC. The controller unit uses two temporary storage buffers to receive blocks of instruction from the DNC computer and convert them into the machine actions, while one buffer is receiving a block of data and the other is providing control instruction to the machine tool, and this is a cost is very less. If you're talking about a special machine control unit, that is SMCU system, in this arrangement a special machine control unit completely replaces the regular control unit with a special machine control unit. This special machine machine control unit is a device that is specially control unit is designed to facilitate communication between the machine tool and the computer. And the special MCU configuration achieves a superior balance between accuracy of the interpolation and fast metal removal rates than is generally possible with the BTR systems. If you if you see the relative feature between BTR and MCU, in BTR system, the interior balance between accuracy of the interpolation and the fast metal removal rate is will be there. And if you see the SMCU system, the superior balance between accuracy of the interpolation and fast metal removal rate, that is will be a balanced one. And BTR systems are hardwired and SMCU systems are softwired. And BTR systems, it more difficult to make the changes in the regular NC controller because rewriting is required here. In SMCU, the control functions can be altered with relative ease to make improvements. And BTR system is cost is very less, and if you see the SMCU, this cost is very high. If you see, you'll see the advantage of NC system is there is various advantages in DNCs are one of them is eliminating of punched tapes and tape readers, and it convenient storage of NC part programming in computer files, and it generates or greater computational capability and flexibility for such functions are circular interpolation and reporting of soft performance and the convenient editing and diagnostic features. The time sharing or in the time sharing or the control of more than one machine by the computer. And last, we can say the remote computer location. The computer is located in the computer type environment only. What if what happens if the computer breaks down? If you see the last one, if the computer breaks down, this has not turned out to be too much of problem simply because the central computer is much more reliable than the conventional NC machines. Yes, and so this is what overall we have discussed or we have gone through the direct numerical control apart. So we'll see you in the next video of next chapter. Thank you one and all.